Got it.
No, I got a new one.
Okay. All right. So we were talking about dividing. Let me warn you, though, that this section, even though it's going to appear easy in the beginning, is going to lead into some concepts that you probably aren't familiar with unless you took pre-calc. And then it's going to lead into 3-4, which is a pretty complex section. So you might want to really make sure you're focusing on this, you know, and kind of keep your little eyeballs up at this screen and not your little tiny screen, you know what I mean, just to get you through this next day or two. So, okay, so the end goal for this chapter is that you're going to get a polynomial that's pretty tough, one that you are not able to solve, right? Not a quadratic, something much, much more complicated. And so the goal is that you leave knowing how to solve that, to find all the answers. Okay, that's where we're kind of headed with this. So one little tool to put in your toolbox to solve that with is synthetic division. You're going to need synthetic division to solve these difficult polynomials. So we talked on Tuesday about the fact we don't do long division and we do synthetic and it's not hard and all that good stuff. So, okay, let's jump in with this problem then. So if you remember with synthetic division, the first rule is this guy here, right? This is your dividend. This has to be in descending order. And it is the third power, second power, first power constant. You also cannot be missing any terms. And we're not. We have a third power, second power, first power constant. So we're good. Okay. So now we're going to take the coefficients of this guy. So this is a coefficient of 1, even though you can't see it. And we're going to write them in a line. We've got 1, then we have 4, then we have -2, and then we have -5. So we wrote all the coefficients. Everybody good with that? Okay. Then we have to take our divisor and figure out what are we dividing by. All right. So we're going to set him equal to 0, and we're going to solve for x. So if I subtract 1 from both sides, I'm dividing by -1. So I'm going to make a little shelf over here and stick a -1 on it. Okay, so let's stop right there and talk about that for a minute. A lot of teachers will just tell you to take the number and change the sign, opposite sign, and throw in a -1 there.
Is that where it's
That's a little dangerous because that works if it says x plus 1, you make it a -1. Sometimes it won't say that. It'll just say divide this by -1. And then if you get in the habit of switching the sign, you're going to think, oh, I put in a +1 here. And so you really, rather than using a trick there, you need to think about what is x? What am I dividing by? You're dividing by whatever x is. If they tell you x equals -1, that's what you put on the shelf. If they tell you it's x plus 1, you solve for x and put that on the shelf, okay? So you're taking whatever x is equal to and putting it there, all right? Okay, so is that okay with everybody on what goes on the shelf there? Okay, now we're ready to start. So we're going to leave a blank because we're going to have to add some numbers in. And we're going to draw a line. All right. Yeah, and we're actually going to add these, which is super strange, right? Because addition goes with multiplication. Subtraction goes with division. But this is how you divide synthetically. Okay, now we take our first term and we bring him straight down to the answer spot. There he goes. And then from this point on, it's kind of like follow the bouncing ball, okay? So here we go. We're going to take -1 times 1, and that goes up here. And then we add and we get a 3. All right, we go back to our shelf, -1 times 3, that goes up here. We get a -3. Okay, we add and get a -5. We take -1 times -5, that's a +5. We put it here and we add and get a 0. So it's kind of like we did, you know, boom, 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 like you're just following the little bouncing ball all the way down, Okay, to start it off though, you have to bring down your first term. And then you're just bouncing along, multiplying everybody by that guy on the shelf and then adding. Okay, does that kind of ring a bell? I know you guys have done this before. Okay, so this very last spot, if you remember, this is your spot for your remainder. Exactly. So in this case, for this particular problem, we don't have one. And that's why I wanted to do this problem, because I want to start off with not having a remainder. Okay, so we're good. We have a 0. Now, this is our answer, but I can't just write these random numbers. I have to write them as a polynomial. So we go back to where we started and we go 1 degree down. So this is an x to the third. Our answer is going to go 1 degree less, and our answer is going to be an x to the second. So then I start filling them in. This is an x to the second, which would make this an x, which would make this a constant. And then I just write it all really nicely with signs in between them. And this is my answer. Okay, is that good? Everybody remember that little guy? Okay, so let's talk about what this actually means. Okay, all right. So what this actually means is that for this polynomial way up here in the top, one of the solutions to this guy is going to be -1. That's what that actually means. So this is a 4-term poly that we are not able to solve because it's not a quadratic. We can't throw it in the quadratic formula. He's 4-term. We could try to group him, but not everybody factors. And this guy's not factorable. So the only way to solve him would be to put him in a graphing calculator and look at his x-intercepts. But when we try dividing him by a number, -1, we realized, oh my gosh, there's no remainder. So one of his answers is a -1. So if we had to do a little solution set, how many answers is he going to have total? 3, right? So he would normally have 3 answers. We don't know the other 2, but we know one of them is -1. Now, why do we know -1 is an answer? Because there's no remainder. That's how we know -1 is an answer, because there's no remainder. If there was a remainder, that one's not an answer. It's not a solution. So then what you're going to learn in the next section is that you would then take this little guy. How many answers is he going to have? 2. Guess what they're going to be? These 2. And then you could either factor him, he doesn't factor, or put him in the quadratic formula to find the other 2. And that's how you're going to solve these giant polynomials, is that you're going to have a number that you test to see if it's a 0, to see if it's a solution. And the way you do that is synthetic division and see if it has a remainder. If it doesn't have a remainder, it's a solution. If it does, it's not, and you'll have to try something else. Does that make sense? Okay, that's the gist of the whole thing. And a lot of students miss that whole concept, but I'm going to keep telling it to you over and over again. Okay. All right. So right now, all we're going to do is divide though. We're just going to keep dividing and see what happens. No, we're not going to finish that. That would be next week's lesson. I was just kind of showing you where we're going with it. That's all. That's all. We're just practicing dividing for now. I'm going to give you every possible issue you could have, and we're going to make sure you can divide. Okay, so let's see. If you have a remainder, you're going to make a fraction with it. You're going to put it over the entire denominator from the original problem. All right, we're going to practice that. Both of these guys have remainders. All right. If my math lab does not provide you with a remainder box, just make a fraction. Sometimes it will. Sometimes they're going to give you a remainder box and there's no remainder. So what if you had this problem and on my math lab, they said, put the answer in here. And then they also did this. Okay. What if that was the answer blank my math lab gave you? Okay, well, this is what goes in here. then your remainder would go in here, but we don't have a remainder. So you're going to put up here what? 0. Okay, so if they give you a remainder box and you don't have one, just put in 0. Okay. All right, so let's practice with this guy. Okay, he's got some issues because the very first little bullet point says, make sure your terms are in descending order. They have to step down. You have to put them in order. Now, don't touch the denominator. That's an issue. Don't touch the denominator. Leave him alone. But you do need to rearrange the numerator. So I'm going to rewrite this in descending order. If I could write, that would be super helpful. Here we go. Okay. All right. Everybody know how to write descending order? Just the biggest exponent. And then you next exponent, next exponent, next exponent. Okay. Say that again to me. Oh, bigger than negative. Okay. So all you want to look at are the exponents, not the coefficients. It's a great question. Okay. So all we're looking at are the exponents and stepping them down. Okay. All right. Let's look at the next bullet. Must use a 0 for any missing terms. Okay. All right. Okay. So that means that I notice that I'm to the 4th. That means I'm going to need x to the 3rd, x to the 2nd, x to the 1st, and a constant. And if I am missing any of the following, I have to put in a 0. Well, I have an x to the 3rd, and an x to the 2nd, and an x to the 1st. Who am I missing? The constant. So I'm going to have to add in a 0. If you're missing any of the terms, even if it's just an old constant, you got to put in a +0. You have to hold his place for him. Okay. All right, technical difficulties. Okay. Now, I'm not worried about the denominator. You want to leave him the way he is. Don't touch him. Okay, it's just the top. All right, now I'm ready to make my numbers. So I'm going to have a coefficient of 1, a coefficient of -4, a 1, a -4, and a 0. Okay, I'm also going to have a shelf. Who's going on the shelf? -4, because if I take my denominator and set it equal to 0, and I solve for x, x is going to equal -4. So that's who goes on the shelf. What I'm actually doing in reality is testing -4 to see, is it a solution of this poly? That's what's actually happening here. Okay, so let's see if he is. Here we go. We're going to leave a blank. We're going to add, and we're going to bring down our first term. Now we're ready to go. Okay, we're going to do -4 times 1 and put it up here, -4. Add these, I get -8. -4 times -8, +32. I'm going to add the 1, I get 33. Okay, this might be where you need your calculator. I got to get my packet out here. Okay, all right. So then I have -4 times 33. That's going to give me a -132. This is not looking good for a no remainder, folks. Okay, add these together, I get -136. Okay, -4 times -136, I get 544. What in the world? Okay, add them together, there's my answer. All right, I think it's safe to say that -4 is not a solution. Everybody agree with that? It is not an answer. What would I have to have for him to be an answer? 0, so definitely not. Okay, so this is my remainder. We'll deal with him in a minute. Okay. All right, now we have to know what exponent to give our solution. So this was x to the 4th. I'm going to reduce it 1, and it's going to be x to the 3rd. So I'm going to throw an x to the 3rd, then an x to the 2nd, then an x, and then a constant. So when I write this over, I get x cubed minus x squared plus 33x minus 136 And now I need a remainder. I can't put like the little baby r and the 544. Remember we used to do that in like second or third grade? Those were the good days. Okay, so this is a positive. So I'm going to do plus 544 over my denominator, my original denominator, exactly the way that it was. And that's my answer. Okay, so we did divide it. We do have a quotient, right? We have an answer to the division problem, but we do not have a solution to the poly because -4 is not a solution to the poly. Does that make sense? Okay, because you can divide anything. It doesn't mean it goes in evenly. Okay, all right. We're ready for the next one? Does that make sense? Okay, all right. Are we in descending order? No, we start out strong with the x to the 5th, but then we kind of lose it. All right. So let's kind of do this in one big step. As we're putting in descending order, think about missing terms. So if I start off with 5x to the 5th, I now need a term of x to the 4th. I don't see one. Do you guys? So we're going to put in a 0 there for our x to the 4th. If you want to do this, some students like to put the x to the 4th there. You can. That's up to you. Or you can just make it a big old 0. Okay, I do see a third, so minus 3x to the 3rd. I see a second, so plus 6x to the 2nd. I see a first, minus 5x, and I see a constant, plus 5. Okay, that was a big one. And then I never touch the bottom. Okay, everybody good on that? All right, let's start making our little problem then. We're gonna have a 5, a 0, a -3, a 6, a -5, and a 5. Okay, who's going on the shelf? +2. If I set x minus 2 equal to 0 and I solve for x, I'm going to get x equals 2. So again, what we're actually doing besides just, doing a quotient is we're testing to see if 2 is a solution to this beast. Okay. All right, here we go. He is, right? All right, we're going to add and bring down our 5. Okay. And then we're just going to multiply. So we're going to do 2 times 5, bring it up here, which is 10, and add. 2 times 10 is 20, bring it up there. We're going to add. 2 times 17, that's a 34. Bring it up here. We'll add. 2 times 40, bring it up here. That's an 80. Yeah, I'm not seeing this working out pretty. 2 times 75, that's 150. And unfortunately, my last number is 155. So that's a remainder since it's not 0. Okay. All right. Then I started off with x to the 5th. So my quotient is going to be x to the what? 4th. Okay. So x to the 4th, x to the 3rd, x to the 2nd, and good old x. Okay, so I'm just going to write him over. All right, and a nice plus 75. Okay, I've reached the end. I need to put that remainder. Now he's positive, so that would be plus 155 over the whole denominator we started with. And there's my answer. Okay. All right, so I think we kind of did that to death. I think we can definitely divide synthetically, right? And decide if there's a remainder, if there's not, it's a solution, that whole sort of thing. Okay, all right, so let's look at our next situation here. Okay. The remainder theorem. Okay, another little tool for our toolbox because you know where we're headed, right? The goal is to solve these big polys. Okay, so if the goal is to solve the big polys, and one of the ways we do that is by testing a number to see if it has a remainder, we can do that with synthetic division. But there is an easier way. Well, so I think it's easier. Some students don't like it. It depends on what calculator you have. If you have the big calculator, it's definitely easier to use remainder theorem. If you don't, then sometimes it's more complicated. So anyway, this is kind of one of those things that you need to be aware of, but whether or not you use it is up to you, okay? So what this means is, of course, this is the mathy way to say it, but what this means is if you are testing a number, so in this case, I'm going to do synthetic division, but what is my x equal to? That's who's going to go on the shelf. That's why it's never a good idea to say, I'm going to switch the sign and put it on the shelf, because we're not switching the sign here. Here, this is clearly telling us x is -5, so he's going to go directly on the shelf. So I could use synthetic division to see if -5 is a solution. Remember, he's a solution if you don't have a remainder. But the remainder theorem tells me if I plug -5 in for my x's, whatever I get is the remainder. So if I get a 0, it's a solution. If I don't, whatever I get is going to be the remainder I would get if I synthetically divided. So that's pretty cool. Okay, so let's just prove that. Let's make sure that's true. All right, so let's do our synthetic division here, first of all. So x to the third, it steps down nicely. I'm in descending order. I'm not missing any terms. So I'm going to go ahead and do 3, -5, -2, +5. Okay, we already decided -5 goes on the shelf, right? Because that's what our x equals. Let's see what we come up with. Okay, I'm going to add and bring down 3. So -5 times 3 is -15. It's going to add to give me -20. -5 times -20, +100. That's going to add to give me 98. -5 times 98 is -490. Okay, when I add 5 to that, I get -485. So this is my remainder. Everybody okay with that? So -5 is definitely not a solution. If I wanted to write this over, because I started with x to the third, my entire quotient would be this situation here with -485. Okay, oh, let's talk about that. Good, yeah, let's go ahead and write it over. All right, so if I were to write it over, good, we have a new situation here we haven't dealt with. We know we have to write -485 and it has to be over something. It needs to be over 2 terms that involve an x, but we don't have that this time. It's going to be x plus 5. How do we know that? Well, x equals -5. So if we move the -5 over next to the x, what do we end up with? X plus 5 equals 0. So that's what's going to go here. Okay, does that make sense? Sure, yeah. Okay, so that's kind of strange. Does that make sense for everybody? You just have to tell me what is the slope of the horizontal line. That's it.
So like what end? Okay.
So whatever that
was like side to side.
good. So whatever the slope of the flat line is, you're going to
So it
put
can
it
be
there.
-6 then.
Nope.
Oh.
Think about it. It's a trick question. You don't even need this. Whatever the slope of the horizontal line is. That's
Okay.
what you'll put there. You're welcome. Okay. All right. So remainder theorem. What the heck is remainder theorem? Remainder theorem is, okay, so this would be one way that we could see if it's a solution. Another way is, what if we plug in -5? What if we actually take f of -5 and I plug it in here? Okay, so everywhere I see x, I'm plugging in a -5. Okay, everywhere I see it, I'm plugging in a -5. All right, well, this is going to be 3 times -125. This is going to be -5 times 25 plus 10 plus 5. Okay, I'm just kind of cleaning it up as I go. I'm just doing it in little baby steps. If you have the big giant calculator, you can throw it all in. Guess what we end up with?
Oh, so we just have to plug in the -5 back into the X.
Yeah. So one way to test and see, are we dealing with a solution or not? Now, some students, they can do synthetic division in like half a second. They're like little synthetic division wizards and they like it and it doesn't bother them. I kind of like it. But some students are like, nope, I can do this faster. So it's up to you. You don't ever have to do remainder theorem if you don't want to. But what it's saying is you can determine if this is a solution by just plugging it in.
So if you plug it in, it gives you 0, then
Exactly. So if you plug in -5 and you ended up with 0, what does that tell you? It's a solution. If it gives you anything else, nope, it's not a solution. So you can do synthetic to find that out, or you can do remainder theorem. Okay. Now here's the only issue is that you are, once we get to the next section, you're still going to have to do synthetic because if it's a solution, because you want this reduced poly when all is said and done. So it's kind of one of those things where I don't know if you really want to do it or not, but that's why I only listed one problem here, but it's available to you. It's just an option if you wanted to do it. Plus, I think it's kind of cool to know, and it's gonna, my math lab's gonna have some problems on it. Okay. All right, so let's go down here to the bottom. Okay, solving polynomials given a 0. So let's read through this. So we know if there is no remainder when dividing, then your divisor is a 0. It's a factor, right? This also means that if there is no remainder, okay, it's a solution. So using this, we can find all the solutions. And I kind of showed you this when we started, right? That there's a way then to solve this and find all the solutions. So here we go. Here are the steps we're going to follow. We're going to use synthetic division to divide the poly by the given 0. They're going to give you one solution. Once you use synthetic division, what happens to the degree of the poly? It goes down a degree. So if you have a 3rd degree poly and you do synthetic division on it, it goes down to a 2nd degree. You can always use quadratic formula with a 2nd degree to find the rest of the solutions, or you can factor, okay? Then it wants you to write all the zeros, including the one that was given, in a solution set. All right, now I know that was a lot, so let's do some examples. Huh? Yeah, so this is kind of what I was talking about. Now, for this little section, for page 15 and 16, the good news is they give you one of the solutions. They give you a starting place. When we get to the next section, they don't give you anything, and you're on your own, okay? But we have a little starting place here. So this says divide and use the results to find the zeros of the function. Okay, we can do this. So, all right. I want you to make one change on this poly though. Make this a plus 47x. We need him to be positive or he doesn't come out. Okay, make sure you make a little change on him. Everybody see that? Otherwise, he's not going to come out. All right, so some of you may be saying, well, wait a minute. If all I have to find are the solutions and I know there's 3, I can factor this, right? It's 4 terms. I can do grouping. Well, good luck. You can try it, but not everything factors. And this guy doesn't factor. So you're on your own if you think you can do it by factoring. We got to have another way to do it. Okay, so this wants us to divide by this. So here we go. I see we're in descending order. We're not missing any terms. So I'm going to do 1, -13, +47, because I made that change, -35. Okay, be careful. Who goes on the shelf? 1. That's who goes on the shelf. Okay, good. All right. And remember, our goal here is to find our 3 answers to this poly. This is our end goal. And I know there's 3 because it was x to the 3rd. Okay, here we go. Let's see. Bring down a 1. All right, 1 times 1 is 1. Add that, I get -12. Okay, 1 times -12, -12. Add those together. Well, this is looking good. 35. 1 times 35. Add them. Look at there. No remainder. So this means 1 is a factor or a 0 or a solution, right? All the same thing. All the same thing. Okay, so that means I've got one of my 3. I get to throw it in. Okay. Even better news is this reduced poly, that's my answer. I can find the other 2 from this guy. Okay, so let's see. I started out as x to the 3rd. So what is this one going to be? X squared with an x. So what I now have is this. Does everybody see what we did there? Not only did we verify we had a solution, we reduced our poly into something we can totally handle. We can totally handle this. Now you can quadratic formula him if you want, but he's factorable. Yeah, he's a monic. There's no GCF. I'm looking for factors of 35. So they either have to be both positive or both negative that give me negative 12. Perfect. They're going to multiply to give me positive 35 and a negative 12. Add for a negative 12. Okay, now we're going to solve these. We can set each one equal to 0 and solve. And this packet, x is going to equal what? Okay. We get 7 and we get 5 because you set it equal. So we go and put them up here and now we've solved and we're done. That's okay. I figured it out. For a minute, I was like, So this was the answer to the problem, but you had to go through this to get it. Does that make sense? Okay, so let's just make sure you're clear on that. We could have taken a positive 1 and put it through here using remainder theorem and known it was a solution. But then we wouldn't have had this reduced poly to factor. So remainder theorem is good for verifying that it's a 0, but you still have to do synthetic because you have to get the reduced poly. Does that make sense? Okay, so that's why it's kind of one of those optional things that may or may not be helpful to you. Okay, let's go to the next one. Alexis is already breaking out in hives. Okay, so here we go. All right, here's our poly. I notice it's a 3rd degree. Okay, you could try to group him, but it's not going to work for you because not everything does that. Because it's a 3rd degree, I know that I'm looking for 3, right? Okay, so here we go. It tells us this is a 0 of the function. So we already know he's going to work. So if you wanted to, you could go ahead and plug him in. They don't always tell you that, right? Up top on the one before us, it didn't. It just said, hey, divide this. But down here, it says this is a 0. So that's kind of nice. We know it's going to work out. Why are we having to use synthetic division if we already know it's going to work out? Because we need a 2nd degree equation. We need a quadratic equation that we can factor. That's why we have to do synthetic. Okay, so I'm going to do 36, 148, negative 65, negative 9. And what's going to go in my shelf? Negative 9 over 2. Yeah. Great question. And that's another thing I want to talk about. So this tells us the 0. That's actually what we're testing, which is going to be negative 9 over 2. We're testing that. We had to change the sign over here so we could figure out what are we testing? What is x equal to? And in this case, x equals 1. That's what we were testing. Here, they're already telling you x equals negative 9/2. They're already telling you that for him. So you put it right in. So again, you have to really be sure you know if you see x plus or minus something, that's when you have to change the sign. If you don't and you just see the value, you put it right in the way it is. Does that make sense? That can be tricky. Okay, I know you hate fractions, but that's what calculators are for. So if you do -9/2 in parentheses and you multiply it by 36, you're actually going to get a -162. So look at that. It's not even a fraction. Okay. Yes. So I did this and I put it right here. Oh, yes. Okay. So you multiply the top, divide the bottom. So -9 times 36 divided by 2. Yep. Okay. Add these up is get -14. -9 times -14 divided by 2, we get a +63. And we get a -2. -9 times -2 is +18 divided by 2, 9. And there's our 0. Okay, good deal. All right. But, and we already put our -9/2 here. Now we're going to have to deal with this guy. So remember, we had an x cubed. So now we're dealing with an x squared. So we're going to have 36x squared minus 14x minus 2. Okay, so now we're going to need to factor him. You can put him in quadratic formula if you want. I already heard Maricela said GCF, right? The first question we should be asking ourselves is, can we pull something out? We can pull out a 2. Okay, so if we divide everybody by 2, we're going to get 18x squared minus 7x minus 1. Okay, now all we're trying to do is find these solutions. So do we need the 2 anymore? If I set 2 equal to 0 and solve for x, is it going to matter? No, so we really don't even need to deal with him since all we're looking for is solutions. Okay, now we are going to need to factor this guy. If you want to do quadratic formula, you can. Let's see if we remember how to factor somebody that's not a monic. Okay, so we're going to do 18 times -1. That's a -18. So somebody's positive, somebody's negative. And if you go through and you list your possible choices for a -18, which one of these could I combine to get a -7? 9 and 2. Okay, we want a -7, so who's going to be negative? The 9, right? Because the bigger number should be negative. Okay, so you can put these in any order that you want, but I'm going to replace my middle term with those. Okay, remember how we did that? It all comes back. Good. So we picked who we wanted, we replaced the middle term. Now we have 4 terms, so we're going to group. Okay, my GCF for the first group is 2x. I divided 2x out, I get 9x plus 1. What's my GCF for that second group? -1, good. When I divide a -1 out, my signs change, and then there's my little checkpoint where they're both the same. Okay, we pull one of those out, and we're left with 9x plus 1 and 2x minus 1. Now don't get excited and circle those. Remember, what are we trying to find? We're trying to find the zeros. So now you have to take each of those and set them equal to 0 and solve for x. So if I take 9x plus 1 equal to 0, and I'm going to take 2x minus 1 equal to 0. I'm going to subtract 1. I get one of my x's is -1/9. Everybody agree with that? Okay. We're going to add 1. Divide by 2. My other x is 1/2. So then I can go back up here and fill in. This would be my final answer. This was a really, really hard problem because it dealt with fractions, because you had to factor something that wasn't a monic. Then each parenthesis packet dealt with fractions again. It was a pretty tough situation. Okay. All right, how do we feel about that? You think we can do it? That would be as hard as it gets for my math lab, not for a test. Okay. All right, last page for this section then. Not that crazy one down there. Huh? No.
Come on.
Come
Let's see
on.
him get it.
Okay, fine. We'll do, yes. Oh, it will be a bonus. You're right. You're right. You're right. But there won't even be fractions. I forgot. Okay, now we have this situation. So use a graph. This is just in my math lab problem. Okay. So this says use a graphing calculator to graph and solve this equation. All right. I know you don't all have graphing calculators, but hopefully you did the little app on your phone, or you can go to Desmos on your calculator, right? I mean, on your computer. This is just a my math lab problem. This is just wanting to kind of cement in your mind that on the graph, what do the solutions look like? Where do you find those answers on a graph? The x-intercepts, right? So what this is trying to do is, okay, trying to make it where both screens can see it, but I'm having trouble with this other little guy. Okay, let's try that. All right, so what you would do on Desmos or your graphing app or your calculator is you would put this guy in. So I would have 4. Now remember, your X button is right here underneath mode. So X, and then I would use my little caret sign to get a 3 and then come down. Everybody okay with how I did that? Okay, let's go do that again. Okay, so I did 4. Then here's my X button right underneath mode. And then right underneath clear, it hops me up to an exponent and I put in 3. And then I hit the over button to come down. Okay, minus 25x. Now you can just hit the square button for this one. It's above log. Plus 38, whoops, x. What in the heck? Okay, hold on. X minus 8. Okay. And then you should be able to just hit graph. Now I'm going to have to hit zoom standard on mine because I was doing something weird on mine a few minutes ago. Okay, and there's our graph. So on my math lab, the very first part of the question is going to be identify the graph. So it's going to give you 4 choices. You would pick the one that looks like that. Okay, so there it is. Now, it also wants you to solve it. So I'm going to have 3 solutions, right? I'm going to have 3 solutions. So I'm going to have 3 x-intercepts. All right, well, I notice I have one here, and one here. Okay, I'm going to zoom in. So I'm just going to do zoom in, and I'm going to click right there and see if that helps me a little bit. And not really. Okay. Let me zoom standard. Yeah, so let's go to the table and see what we can find on the table. Okay, so remember your table is under right here by graph. So I'm going to do second graph and look at my table, and I'm going to kind of zoom around here. Okay, anywhere that y is 0, anywhere you have an x-intercept is an answer. So I notice that I have 2, 0. So one of my answers is 2. I notice I have 4, 0. One of my answers is 4. And then I noticed I had one that was kind of somewhere between 0 and 1. It was awfully close to the origin, but it's not showing up on the table because it's not a whole number. Okay, so I'm going to go back to my graph. So here's my 4, here's my 2. It's this one that I want, but I can't quite get it. Okay, so you could do a couple of things. You could do synthetic division with a 2. It would knock it down. Then use that answer, do synthetic division with a 4. It would knock it down. And then it would solve that last one for you. Okay, or they just want you to know there is a way to find it on here. And how we would do that is second calc, okay, or second trace. All right, then you're going to click 0. Okay, so here's 0, he's number 2. Okay, then you're going to be somewhere, oops, where did I go? I lost my, there, well, okay. Then you're just going to kind of go up and down here a little bit. So it says left bound. Here's my little guy right here, and it's over here on the left. So then I'm going to click yes for left bound. I'm going to click enter. And then I'm going to click to the right until I get past my intercept. And that says right bound. Yep. And then it says guess. Yep. And then it tells me exactly what that is. And this tells me it's x equals 0.25. So you could put 0.25, or does anybody know what that is as a fraction? 1/4. Okay. And there you go. So it's not, we're going to do the last problem because we got time to squeeze him in, by the way. But just so you know, you only have one of those. It's on my math lab. So that will kind of help you get through that, but it's not the end of the world if it gives you trouble. But Desmos should help you with that, or your calculator. Okay, let's look at this one. All right, so this one has the poly. It's an x to the third poly. So we're guessing there's 3 solutions here. And it gives you a little window. So this would be 0. This is 5. Every tick mark is 1. And then it gets a little crazy on the y-axis, right? Okay, so which solution of the equation can be determined from the graph? Well, the graph crosses the x-axis in one place. So what number is this? 1, 2, 3. So one of your solutions is 3. That's the one that you get from the picture. Okay, now it wants the other 2 solutions. Okay, well, we can't tell those from the graph. So how are we going to find the other 2? Synthetic. I'm going to have 1, 5, -9, -45. Now be careful here. Who's going to go on the shelf? 3, because x equals 3. Okay. Bring down my 1 to 3. Bring them down, I get an 8. 3 times 8 is 24. Add that, I get 15. 3 times 15 is a 45. Sure enough, and we expected that to give us a remainder of 0. Okay, now we're going to use this reduced poly, but we need to factor him to find our other 2 solutions. So we want factors of 15 that add to give us 8, 3, and 5. Okay, now be careful because we're not going to put x equals 3, x equals 5. What is x going to equal? -3 and -5. So the set of the other solutions is going to be -3, -5. Okay, and there you go. All right, so that finished 3, 3 for us.